In the late summer of 2022, a hauntingly beautiful, hyper-detailed image of a sweeping space opera took first place at the Colorado State Fair Fine Arts Competition. The judges were captivated, but the victory instantly ignited a global firestorm. The creator had not used a brush, a canvas, or even a digital drawing tablet. Instead, they had typed text prompts into an algorithmic engine. This moment shattered the illusion that creativity was an exclusively human domain, thrusting the world into a complex new reality where lines of code can synthesize masterpieces in seconds. That engine was just one of several rapidly advancing platforms that have since reshaped the global digital landscape. Systems like Midjourney, DALL-E, and Stable Diffusion have unleashed an unprecedented explosion of algorithmic media. Anyone with an internet connection can now summon intricate, photorealistic images, surreal landscapes, or precise technical illustrations simply by describing them. But beneath the surface of this technological marvel lies a sprawling, high-stakes battlefield. The core of this conflict is not about what these systems can produce, but rather exactly how they acquired the ability to produce it. To understand the controversy, one must look at the underlying architecture of generative AI. This term refers to artificial intelligence systems capable of generating new text, images, or other media in response to human prompts. In the visual realm, these systems often rely on a framework known as a diffusion model. A diffusion model is trained by taking millions of existing images, gradually adding digital noise until the original picture is completely destroyed, and then teaching the neural network to reverse that process, mathematically reconstructing a coherent image out of pure static. The critical variable in this mathematical alchemy is the training data. For the neural network to successfully reconstruct an image of a golden retriever painted in the style of Vincent van Gogh, it must first be fed vast quantities of images featuring golden retrievers, alongside extensive galleries of Van Gogh's actual paintings. To achieve this, technology companies scrape the open internet to build colossal datasets, pulling in 5.8 billion images, photographs, and digital illustrations. This monumental ingestion process happened largely in the background, without fanfare, and crucially, without the explicit consent of the original creators. The realization of this mass data extraction sent shockwaves through the creative community. Artists woke up to find their entire portfolios, representing decades of honed skill and personal expression, had been absorbed into the machine. The algorithms were not just learning general concepts of light and shadow. They were mathematically mapping the distinct, recognizable styles of living, working professionals. The ethical dilemma crystallized immediately. The technology was built on the uncompensated labor of the very people it was now poised to compete against. This ethical outrage rapidly transitioned into a fierce legal war over copyright law and intellectual property. Multiple class action lawsuits have been filed by groups of artists against the creators of Midjourney, DALL-E, and Stable Diffusion. The plaintiffs argue that scraping copyrighted images to train a commercial algorithm constitutes mass infringement on an unprecedented scale. They contend that every output generated by these models is essentially a derivative work, fundamentally reliant on the stolen intellectual property of human artists. In response, the technology sector has deployed a formidable legal defense centered on the doctrine of fair use. In United States copyright law, fair use permits the limited use of copyrighted material without acquiring permission from the rights holders, typically for purposes like criticism, news reporting, teaching, or research. The tech companies argue that training an artificial intelligence is a highly transformative process. They claim the models do not store or copy the original images in a database, but rather extract abstract mathematical relationships and statistical patterns, much like a human art student studying the masters in a museum. But the human art student analogy begins to fracture when subjected to the sheer scale and economic realities of algorithmic generation. A human student might spend years studying a specific illustrator's technique to produce a handful of homage pieces. A generative model can produce 10,000 highly accurate stylistic mimics in a single afternoon, flooding the market and directly undercutting the original artist's ability to secure commissions. The speed and volume of this production fundamentally alter the market dynamics of the creative industry. This market displacement is not a theoretical future scenario. It is happening right now. As reported by creative industry guilds, book cover illustrators, Concept artists in the video game sector and freelance graphic designers are experiencing a sharp decline in contracts. Corporations and independent clients alike are increasingly turning to prompt engineering to fulfill their visual needs at a fraction of the cost and time. The artists whose life work trained the models are finding themselves priced out of the very industries they helped build, replaced by an automated system wearing their own stylistic fingerprints. As the courts grapple with the legality of the training process, a second, equally profound legal battle is unfolding at the output stage. The United States Copyright Office has been forced to make definitive rulings on who, if anyone, owns the art an algorithm creates. Repeatedly, the office has rejected copyright applications for images generated entirely by text prompts. Their rationale hinges on a foundational pillar of intellectual property law: the absolute requirement of human authorship. The Copyright Office maintains that copyright protects only the fruits of intellectual labor founded in the creative powers of the human mind. Because the generative model dictates the final arrangement of pixels, the lighting, the composition, and the specific visual execution based on a brief text prompt, the human prompter is viewed more like a client giving instructions to a commissioned artist rather than the artist themselves. Without a substantial, measurable degree of direct human execution, the generated output falls immediately into the public domain. This rigid stance on human authorship is forcing a rapid evolution in how creative professionals interact with these tools. To secure legal protection for their commercial projects, artists are developing hybrid workflows. They might generate an initial concept using an algorithm, but then spend hours digitally painting over it, altering the composition, and adding intricate human-driven details. The legal threshold for exactly how much human intervention is required to transform an uncopyrightable machine output into a protected intellectual property remains a blurry, highly contested frontier. Frustrated by the slow pace of the legal system, the creative community has begun fighting back with technological countermeasures. Computer science researchers at major universities have developed sophisticated software tools designed to poison the training data before it can be absorbed by the web scrapers. Programs with names like Glaze and Nightshade allow artists to apply an invisible layer of digital noise to their online portfolios. To the human eye, the artwork looks completely normal, but to a data-scraping algorithm, the image is fundamentally corrupted. This data poisoning attacks the neural network's ability to accurately categorize visual information. If an algorithm ingests enough poisoned images of a cat that its mathematical architecture perceives as a purse, the model's internal logic begins to degrade. When a user later prompts the system for a cat, it might output a bizarre, distorted leather handbag. By actively disrupting the training pipeline, artists are attempting to force tech companies to the negotiating table, making the unauthorized scraping of the internet a technically hazardous endeavor. The escalating friction between data scrapers and data poisoners has accelerated a pivot toward a new commercial model: ethically sourced, fully licensed generative systems. Several major software corporations, leveraging their massive proprietary stock image libraries, have launched their own algorithmic tools. Because these companies already own the copyright to the millions of images in their databases, they can train their models without fear of infringement lawsuits, offering enterprise clients complete legal indemnification for any artwork generated on their platforms. This shift is creating a two-tiered ecosystem in the world of algorithmic media. On one side are the sprawling, open internet models, possessing vast capabilities and diverse styles but carrying immense legal risk. On the other side are the walled gardens of licensed models, offering legal safety but potentially limited by the stylistic constraints of their proprietary training data. The success of these licensed platforms proves that it is entirely possible to build powerful generative systems while respecting existing copyright law and compensating original creators. Beyond the immediate legal and economic skirmishes, this controversy is forcing a deep philosophical reckoning with the very definition of art. For centuries, the value of a visual work was inextricably linked to the physical skill, the time, and the emotional intent required to execute it. Generative technology severs that historical connection, completely decoupling the ideation phase from the execution phase. A person can now possess immense imaginative vision without possessing any technical drawing ability whatsoever. This separation demands a reevaluation of where the true artistry lies. Is the art in the final arrangement of pixels on a screen, or is it in the curation of the prompt, the iterative refinement of the text, and the selection of the best output from a sea of algorithmic noise? As the technology advances, prompt engineering is evolving from a casual novelty into a highly specialized skill, blurring the lines between a traditional artist, an art director, and a software operator. The stakes of this debate extend far beyond the realm of visual illustration. The legal precedents currently being forged in the crucible of algorithmic art will inevitably dictate the future of all generative media. The exact same legal arguments regarding fair use, mass scraping, and derivative works apply to large language models trained on copyrighted books and articles, as well as audio generators trained on the vocal stylings of famous musicians. Visual artists are simply the first wave of knowledge workers to face the full, unmitigated impact of algorithmic replication. The court rulings that emerge from these copyright battles will establish the foundational rules of engagement for the entire artificial intelligence economy. If the courts ultimately rule that mass data scraping is a protected fair use, it will signal a massive transfer of value from individual creators and copyright holders directly to the technology sector, fundamentally altering the economics of human creativity. Conversely, a sweeping regulatory mandate requiring explicit consent and licensing for all training data would radically alter the trajectory of the technology sector. Companies would be forced to dismantle their current models, purge unauthorized data, and negotiate complex, expensive licensing agreements with millions of individual rights holders. This regulatory outlook would democratize the financial benefits of the technology, but it would also erect massive barriers to entry, potentially consolidating artificial intelligence development among the few massive corporations wealthy enough to afford the data. To find a historical parallel to this current societal anxiety, one must look back to the mid-19th century and the invention of the camera. When photography first emerged, traditional portrait painters were terrified. They argued that a machine capable of capturing reality in an instant would render human artists completely obsolete. They fiercely debated whether a photograph could even be considered art, or if it was merely a soulless mechanical reproduction devoid of human spirit. Yet, photography did not destroy painting. Instead, it liberated painters from the burden of strict realism, directly catalyzing the birth of Impressionism, Cubism, and modern abstract art. The camera simply became a new tool, requiring a different set of skills regarding composition, lighting, and timing. The current algorithmic revolution holds the potential for a similar trajectory, pushing human creators to explore new frontiers of expression that machines cannot easily replicate, forcing a renaissance in how we define human ingenuity. The ultimate resolution to the copyright battle over generative media will not be found in a single court ruling or a solitary technological countermeasure. It will require a comprehensive, societal renegotiation of how we value human labor, how we define intellectual property, and how we choose to coexist with machines that can seamlessly mimic our greatest creative achievements. The canvas of the future is currently blank, and the laws being written today will determine exactly whose hands get to hold the brush.